have river and fish in the river. And we know that fish in the river have 340 grams of weight on average, with standard deviation sigma equal 30 grams. And we assume that they have normal distribution of weight. We need 1 kilogram of fish for lunch. Let us find the probability that 3 caught fish are enough for lunch. Second, that 3 fish have weight above average. And C, their mean weight, the mean weight of 3 caught fish is above 350 grams. Okay, so in the first case, what do we consider? We take 3 fish caught, so we produce a new random variable equal x1 plus x2 plus x3. And based on the previous theorem, what do we have? If xi have normal distribution with mu equal 314 and sigma squared equal 30 squared, then a sum of these will have normal distribution with mu equal, let's call it mu3, 3 times 314, and variance is sum up of variances, so this is 3 times 30 squared. Okay, so 3 fish are enough. It means that the sum will be bigger than 1 kilogram. So we find probability that x is greater than 1000. Now let's use the standardization formula. So this is probability that z is greater than 1000 minus, what is the mu? 3 times this is 1020 divided by, what is the sigma 3? It's square root of 3 times 30. Okay, so we have 30 square root of 3. It's better to write like this. Okay, so we have probability that z is greater than 20 minus 20 divided by 30 square roots of 3, so this is minus 2 over 3 square roots of 3. Okay. We have some negative z minus 2 over 3 square roots of 3. We want this. So this is the same as from this to the left. So probability that z less than 2 over 3 square roots of 3. And now we can use the table of cumulative distribution function. And this is equal to 0.648. Now question B. We have all the 3 weights are above average. What's the probability that a caught fish is above average? It's exactly a half, because we know that 50% are above and 50% are below average. Okay, so now we have like binomial distribution where y number of successes. Well, probability of success is a half. So either a fish is above or below, and with equal probability a half. So the probability of y is equal to 3 is 3 choose 3, a half to power 3, and a half to power 0. So this is 1, this is 1, this is a half to power 3, so this is 1 over 8. And that's it. Okay, and question C. Their mean weight is above 350. Their mean weight. what do we have now? What's the distribution of the mean? We know that the mean will have distribution, which is normal, with the same mean as before. So mu is also 314, and the variance of the mean will be the variance of the population divided by n. But we have 3 cot, so we have 30 squared divided by 3. So the standard deviation of this distribution is 30 divided by square root of 3. And now, referring to our question, probability that the mean is above 350 is exactly probability that z is greater than 350 minus 340 divided by standard deviation is 30 by square root of 3. So this is 10 over 30, so this is 1/3. So this probability that z is greater than square root of 3 by 3. So this is probability z is greater than 0.577. So this is 1 minus probability z is less than 0.577. Okay, so this is 1 minus 0.72, which is more or less 0.38. So now you have the following example. We are producing screws. Their length has normal distribution with mean 3 centimeters and variance 0.04 centimeters squared. Now, the question is, we are to take a sample, so a number of screws. How big should be the sample taken in order that the mean of sample was in the interval 3 plus minus 0.1 centimeters. So let's have a look at the graph of normal distribution. Okay, so this is like 3 centimeters. Then we are interested in 3.91 and 2.1, and we want to have 99% sure that the mean will be here. Okay, but let's start with random variables. What do we practically know? We know that an ordinary screw has normal distribution with mu equal 3 and variance sigma squared equals 0.04 centimeters squared. So it means the standard deviation here is 0.2 centimeter. Okay, but now we take a sample of n. We take n element, we take n screws. So they make a sample. What will be changed? Based on the previous theorem, what do we know? We know that the sample has some mean. The mean of the sample, let it be denoted by x dash. X dash, it so happens that n, the mu of this mean, is also 3. But the variance is a little bit different. The variance dash squared is variance squared divided by n. In other words, the standard deviation will be the previous standard deviation divided by square root of n. So this is 0.2 divided by square root of n. Okay, so this is the mean. That's the distribution of the mean of the sample. Now, what do we expect now? We expect that probability that we are between 2.9 and 3.1. Let's standardize it. 2.9 2.9 minus 3 over this 0 2 by n is z. 3.1 minus 3 by 0 2 by square root of n is 0.99. Okay, we have to simplify this. This is minus 0.1 over 0.2, so this is probability that minus 0.1 by 0.2 times square root of n z, and here we have 0.1 by 0.2 square root of n equals probability minus square root of n by 2 z square root of n by 2. This must be equal 0.99. Well, now let's look at standard deviation, standard normal distribution. Let's have a look at standard normal distribution. We want to be between some minus square root of n by 2 and plus square root of n by 2, and we wanted to have 99% here. So what does it mean? We want to have 0.5% here and 0.5% here, okay, and 0.5% here and 99% here. So practically, if we want to use the cumulative distribution function, we're searching for this point, but the cumulative distribution function at this point should be 1 minus 0.5%, okay? So f of this should be equal 0.995, okay? In other words, probability that z is less than square root of n by 2 should be equal to this. Oh, so let's now find the inverse of, that's phi. So let's now find the inverse of phi to minus 1 of 0.995. This is 2.575. That should equal to square root of n by 2. We'll multiply both sides by 2. We obtain square root of n should be twice 2.575, which is 5.150. So now let's square the two sides, and we have n equal 26.5, but we cannot take 26.5 of screw, so we have to take 27. Okay, so if we take 27 screws, you are 99% sure that the mean of the sample will be between 2.9 and 3.1. Okay, so the answer is take 27 screws.